welcome to the 2016-2017 school year. I'm Mrs. Cedarholm, and this is Algebra 2, which for most of you will be the most important mathematics class that you take in high school, because this is really where you get your preparation for the MCA test that you have to take as a junior. And we start with, obviously, section 1.1 here. Algebra 2 lesson 1.1 is called Patterns and Expressions. And our objective here is probably something that we would want to highlight. So, go to my tools, and you guys hopefully have a highlighter. If you don't, they'll be in the bags that are next to your desks in class. But that objective is huge. We want to be thinking about that as we go through all of these problems. Am I able to identify and describe patterns? And that's what we have to be able to do in this section. So the essential understanding is you can represent some patterns using diagrams, words, numbers, or algebraic expressions. So we have different ways that we're going to be going after these patterns. In the end, what we really want to do is come up with an algebraic expression to tell someone what the 5th term is, the 6th term, the 28th term is. So our essential understanding, I would probably want to highlight that as well. Because that's telling me there is more than one way that I'm going to be able to do this. Now we have a key concepts box, and that is always helpful when we go through a section to tell us, okay, what's important here? What do we need to know? Maybe vocab-wise, or maybe it's a property or a theorem of some kind that tells us some information that we need to use. But this is not geometry, so we don't necessarily focus so much on why we're doing what we're doing as we do on making sure that we can find a phrase, find a mathematical expression for these things. So variables and expressions, we have an N and an X. Both of those are variables. So a variable is a symbol, usually a letter, that represents one or more numbers. Whenever you see a box in your note packet, that indicates that you should be writing something in. Usually a little piece of vocabulary that we have to make sure we know. Pretty obviously, we need to know a variable when we see it. And a variable is just a letter that really is a placeholder for a number. For the time being, we just leave it in the expression. But eventually, we might want to put a number in there. Then the next things that we see here seem like some really basic math. 3 plus 5. The quantity 8 minus 2 plus 5. So those have numbers in them, but they don't have any variables. And they also have plus, minus, and plus. That makes it a numerical expression. It has numbers, so that's the numerical. And the expression part, well, expression is just a way of saying we don't see any equals in this. So with an expression, we have these little lines off to the side for you here. And this would be a good time to use that to write in the side, okay, what do I need to know about an expression? An expression does not have an equals bar. Now, I know many of you probably are already driving, and when you take your driver's test, one of the problems that they have on the driver's test nowadays is, what does that mean? Well, it means don't do it. So an expression will never have an equals in it. If it has an equals, it's called an equation. So this one is a numerical expression, a mathematical phrase that contains numbers and operation symbols. Down here, we see, hey, wait a minute, this one has a variable in it. This one has a couple of variables in it. So this is algebra. It has variables in it. That's an algebraic expression. That's a mathematical phrase that contains one or more variables. So vocab that we use, a lot of people accidentally say equation every time they deal with something in algebra. They're not all equations. If we don't have an equals, they're called expressions. So these are the type of things we want to be able to write today. Some algebraic expressions, which means we're going to have some variables and probably some numbers. But to start off with, we get to problem number 1. And I was just thinking about these lines again over here. And the things that you should write down over on the side are things that maybe I say, but I don't necessarily write down. So things teacher says that really make the lesson pop for you. You know, the one thing that I say that says, oh, that makes total sense now. You know, maybe with what I was talking about earlier, you're going to write down that an equation has an equals, because it does. Not an expression, but an equation. So the lines that are off to the side here, those are for you. Anytime I'm talking about something and you're thinking, oh yeah, that made the light bulb come on, now I've got it, you probably want to write that down off to the side. Problem number 1 says we're going to identify a pattern. Look at the figures from left to right. What is the pattern? So take a second now, see if you can figure out the pattern. And then it says, what would the next figure in the pattern look like? Well, of course, we see the triangle, and it might be a square or a rectangle. Without markings, we don't know. And then we see a 5-sided figure, and that's called a pentagon, and a 6-sided figure, and that's called a hexagon. And we notice, hey, if we look at this, according to the number of sides, this one has 3, this one has 4, this one has 5, and this one has 6. So what is the pattern? The polygons increase by one side length each time. That's a description of what the pattern is doing. So it also asked us, what would the next figure in the pattern look like? Well, 3 sides, 4 sides, 5 sides, 6 sides, pretty obviously it would have 7 sides. And we're just going to have to do the best we can here. I cheated and grabbed a heptagon from my smartboard, but if you don't have that ability, I mean, if you're just trying to draw it, what you want to do is just try and think, okay, 7 sides, how can I get this to work? So I've got 2 so far, 3, 4, 5, and then I realized this one's a little bit longer. Let's shorten that up. And you just try to make a go of it. You know, that's all you can do. And 1, 2, 3, 4, 5, 6, 7. But we also could write down the name of a 7-sided polygon, which is a heptagon. And that would help me when I'm trying to grade your papers know you knew exactly what you needed to do. You know, the drawing maybe didn't go exactly the way that you planned on it, but you've got the 7 sides and you know it's a heptagon, and so I could give you the points for that. And that's what I want to do. I want to be able to give you points for what it is you've done right. On the next page it says use the pattern to answer each question. And the question for A is how many toothpicks are in the 20th figure? So what we want to do is use this table that says figure number, process number, column, and number of toothpicks, the output, and think about what we have here. So figure number. Well, this is figure number 1, 2, and 3. And they want us to look at the output, which is the number of toothpicks. So in figure 1, we have 1, 2, 3, 4 toothpicks. Figure 2, 1, 2, 3, 4, 5, 6, 7, 8. Figure 3, at this point we realize each one of these smaller figures, which would really be a square, has 4 sides. So 4 times 3 would be 12. So the process column is to figure out how could we get this? I mean, is there some kind of formula we could use to get the 4 and the 8 and the 12? And it doesn't take us long to see, well, there was one figure and it had 4 sides. Then for the second one, there were really 2 squares and they had 4 sides. And for the third one, 4 squares, 3 squares. They had 4 sides each. And if you take 1 times 4, you get 4, 2 times 4 is 8, and 3 times 4 is 12. And remember, that's the way I actually counted that last figure, was by saying, you know what, they all have 4. Well, just use 3 of them this time. So 3 times 4 is 12. So when I look at this, I figure out, wait a minute, these are both 1s, these are both 2s, these are both 3. So if I wanted to figure out the 20th figure, I just have to take 20 times 4. That's all I would have to do to figure out how many toothpicks I have there. Now, for B, we go after the algebra piece. What's an expression that would describe the number of toothpicks in the nth figure? So if we change this to n, so instead of 20 times 4 equals 80, we said, don't know it. I know it's n. I know you can find it by doing that. Well, if we turn that around and put the number in front, that number is called the coefficient, and we put the coefficients in front of the variables, we have ourselves an algebraic expression. And this would allow somebody to ask you, how many toothpicks are in the 50th figure? And you could just put a 50 in for n. You could substitute that in there and say there's 200. And you'd have it very quickly and easily. So overall, our plan is to always try to figure out an algebraic expression, but sometimes that's just too difficult to do. So there are times when we end up just describing the pattern. So here's a got it. It says how many tiles are in the 25th figure in this pattern. Use a table of values with a process column. So what they want us to do is really come up with a formula where we're thinking about the n. But we have a process column in the middle. And we have an input. And we have an output. Well, we have the first, second, and third figure. And somehow we want to get this so we can figure out the 25th. So go ahead, pause the video for a second, fill that output column first. How many tiles do you see? Then think your way through a formula that we could use. Now, start that video. As you start the video back up, you're going to hear me explain what I see here. So this one has 4 tiles. This one has 6 tiles. And this one has 8 tiles. So the formula for us is not as clear cut as it might have been before. So what we're going to do is we're going to use this process column to figure out if we can come up with a formula for this. And if it's the 25th figure of the pattern, we don't want to sit and say, okay, the outputs are going to consistently go up by 2s. So 4 would be 10, 5 would be 12. That's just going to take us all day. We'd like a formula. Now we look at it and we should be thinking from 4 to 6 to 8, those numbers are going up. If they're going up, there are things we can do to numbers to make them go up. And that would be the easiest way, would be to add something. So the first thing I see is that if I add 3 to 1, I get 4. But if it's a pattern, that means I have to be able to do it for the other figures as well. Not going to work. So addition is out. Other things that make numbers get bigger. Well, multiplication. So we check and see, is there some multiplication that'll make this work? 1 times something gives you 4. Well, 1 times 4 gives you 4. But is 2 times 4 6? No. Now, it also could be something with powers. But since this is an introductory lesson to your Algebra 2 book, chances are pretty good it's not going to be powers. So instead of multiplying by 1, the next thing that I could do would be multiply it by 2. So if I take 2 times 1, that's only going to give me 2. That won't give me 4. But if I then use a combination of addition with that, I'll have 2 plus 2, which equals 4. All right, let's check it out with the next one. Will 2 times 2 plus 2 give us 6? Yes, it's 4 plus 2. Will 3 times 2, actually I should reverse that in the parentheses like I did the other ones so that you can follow it. Will that give me 8? And the answer is yes. So now you look back at your process column and you notice, okay, I need a variable here. What do I put a variable in for? Well, when things are variables, it's because they change, they vary. This is where we go from a 1 to a 2 to a 3. So the formula for this would really be 2n plus 2. So if we take 2 times 25, because we want to figure out how many tiles are in the 25th figure, that will give us 50 plus 2, which just happens to be 52 tiles. So this one would take a little bit of work to figure out, as far as the pattern goes. Describing it, well, we could describe it in words, but that's not what they asked us for. You go back to it and it says how many tiles are in the 25th figure in this pattern. Now, there could be another way to look at this pattern. You could say to yourself, I noticed that if I take 2 times 2, I get 4. So how do I make a 1 a 2? Oh, easiest thing to do would be to add 1. Let's see if that works for the second figure here. All right, so if I put a 2 into this formula, am I going to get 6? 2 plus 1, by the order of operations, we do parentheses first. 3 times 2, 6. Bingo! I got it. Let's try 3. That has to work for all of them. So if I put a 3 in here, do I get 8? 3 plus 1 is 4. 4 times 2 is 8. Now, those are 2 completely different formulas. Look at this one and look at this one. No, they're not. You guys remember from exponential algebra, if we distribute this 2, it's going to say 2n plus 2. But it's just 2 different ways of thinking your way through the pattern. And that's what we want to learn to do. One way or the other, we want to be able to see that we can develop an algebraic expression that will show us that pattern. Next up, we have some extra examples, and it says identify a pattern and find the next 3 numbers in the pattern. Now, it doesn't say we have to come up with an algebraic expression. If we can, we like to do that. So in order to make this an easier process, a lot of times what I'll do is write the position of the number. These numbers, 2, 4, 6, and 8, that's called a sequence of numbers. And so I try to figure out, well, is there something easy I could do to 1 to get 2, and 2 to get 4, and 3 to get 6, and 4 to get 8? Yeah, well, what I have to do is multiply by 2. Well, this is my n. This is what's varying up here. So my formula would be 2n. That would be a great answer to this problem. If somebody else says, identify a pattern and says, I'm going to do this in words, I could say, starting with 2, write the multiples of 2. Perfectly acceptable answer. It would get them 2, 4, 6, 8. Now the ... in algebra, that indicates that it's going to go on forever. So we are describing a pattern that's going to go on forever. And then it says find the next 3 numbers in the pattern. So however you want to do that is up to you. But generally what I'll do is say, all right, I need 5, 6, and 7 for my table. I had 4. 4 gave me 8. And I've got my nice little formula here, 2 times n. Well, this is n. So 5 times 2 would give me 10, 6 times 2 would give me 12, and 7 times 2 would give me 14. Those are the next 3 numbers in the pattern. And this is something that when I look at it, I could follow it and see you knew exactly what you were doing as you go through this. So lots of different ways to answer these. Because it says identify a pattern, we do not have to write an algebraic expression for it. We can use just plain old words. So with this one, 1, 4, 16, and 64. I started thinking, well, it's not adding by 3. The numbers are going up, so I would try addition first. That's not consistent here. They're not always adding 3. But if I multiply 1 times 4, I get 4. And if I take 4 times 4, I get 16. And if I take 16 times 4, look at that, I get 64. So what's really happening here is that the pattern is you're going to multiply by 4, starting with the number 1. Multiply by 4, starting with the number 1. All right, I probably better put that in as a word too, so when you look at it later, when you look at your notes, you're going to see that. So multiply by 4, starting with the number 1, and there it is. So to get the next numbers in the pattern, we're going to need to do some more multiplying by 4. So if you have a calculator, you sure could use that. But we could also do this longhand. You know, not everybody has their calculator up and running for the year. So we'll get 256. And we'll have to go again. Remember, we were supposed to give them the next 3 terms of this. So we've got 24, 22, 1024, and then we have to go one more time. 16, 9, 0, and 4. You know what? Because I'm using commas to separate these, I am not going to put a comma behind that 4. And there are the next 3 terms. So we've done exactly what they wanted. That's the last thing you always want to do with a problem is go back and say, what did they want me to give them? They wanted us to identify the pattern. We multiply by 4, starting with the number 1. And then we had to find those next 3 numbers in the pattern. 256, 1024, 4096. All right, I want you to take a look at C. And I want you to figure out what is the pattern, and then find the next 3 numbers in the pattern. And this one is 5, 11, 18, 26, and 35. Go ahead and pause the video and see what you can do with this one. So as you start back up, addition, they're going up. It would be the first thing to check. They're adding 6. Then they add 7. Then they add 8. And then they add 9. Well, there's a pattern there. What they're doing is starting with 5. Add the next integer. Now, integers are the set of numbers that have no fractions and no decimals, and they go on in the positive and negative numbers forever. So the integers are coming from the left-hand side, -3, -2, -1, 0, 1, 2, 3, etc. So if they have 5, they add the next integer, which is 6, and that gives them 11. And then they have to take 11 and add the next integer, and that would get you 11 plus 7 is 18. So with this one, we want those next 3 numbers in the pattern. Well, that means we have to add 10 to 35, and that would give us 45. Add 11 and get 56. Add 12 and get 68. So those would be 45, 56, and 68. Again, when we're writing sequences of numbers, the commas are used between the numbers to indicate here's the break. That way the numbers don't run together when somebody looks at them. All right, let's go through this again with D. Go ahead and pause the video and see what you get. With this one, because it's going up again, first you'd try addition and you'd say, well, 1 plus 1 is 2, but 2 plus 1 is not 4, so it's not going to be addition. And you look at the multiplication and you say, wait a minute, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So here, starting with the number 1, multiply by 2. Multiply by 2. Again, so that the numbers don't get mixed up here, I'll go ahead and spell that out. So 1 times 2 gets you 2. Then you take 2 times 2, that gives you 4. Then you take 4 times 2, and that gets you 8. So you start with the number 1, and then you follow the directions. Always multiply by 2. Now, are there other ways to do this problem? Absolutely. You notice, wait a minute, multiplying by 2, isn't that what you do when you raise something to a power? You just keep multiplying by that number again and again and again. So 1 is the same thing as 2 to the 0. 2 is 2 to the first. 4 is 2 squared. 2 to the third. 2 to the fourth. But like I said, this is an introductory section, so they're probably not going to use a whole lot of powers. But if they did, we would have to say to ourselves, we know it's 2 to the something. Now that something has to make a 1 a 0, a 2 a 1, a 4 a 2, an 8 a 3, and a 16 to be a 4. So this one could take us a little bit of time to figure out what's going on. But what we really would have to do is say, well, this was figure 1, this was figure 2, 3, 4, if these were pictures. So then, how do you make a 1 a 0, a 2 a 1, a 3 a 2, a 4 a 3, and a 5 a 4? Well, you take your variable and you would subtract 1. So it's another way that you could write this. If you wanted it as a formula, that's what you would have to do. Because if we want the first number, which happens to be a 1 here, we'd put a 1 up here. And 1 minus 1 is 0, and anything to the 0 power is 1. So it's a different way of thinking. And then we needed to tell them what the next terms were going to be again. So we'd have to take 16 times 2, and that would give us 32. And I'm going to write that over here since I'm going to run out of space. 32 times 2, which would be 64. And then 64 times 2, which would be 128. So another pattern and a couple of different ways to describe it, whether or not it's algebraic or just a word description. Pause the video and give E a try. This is where I get upset that I'm not able to have everybody in class and ask you about this, because I'm sure that some of you have seen the sequence before. This sequence is called the Fibonacci sequence. And the Fibonacci sequence is really unique because it takes a little bit for you to find it if you haven't experienced it before, haven't seen it before. But notice that 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. So how do you put that in words? Well, we would start with 1 and 1. And then what we have to do is add the terms together to get the next term. Add the terms together to get the next term. So we read these directions and we say, all right, it's going to be a 1 and a 1, add the terms together, and we'll get a 2. But now we're kind of stuck. So these directions, they're almost there, but we're missing a little piece here. If we have them write down the 1 and the 1, it's because we need 2 terms together. So add the 2 terms together to get the next term. And that would be a better description, a more complete description of what we needed. So now we go back and we know we're supposed to find the next 3 terms. So we say 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34. And we have the next numbers in that Fibonacci sequence. Now, flashback from exponential for a lot of you here. Oh, look, a graph. I remember doing graphs. Those were cool. They went so fast. But it's been a while since you did this. So using a graph, aquarium. You want to set up an aquarium and need to determine what size tank to buy. The graph shows tank sizes using a rule that relates the capacity of the tank to the combined lengths of the fish it can hold. Oh my goodness, Cedar Home, it's been an entire summer, and that had a lot of words in it. It did. Here's what it's saying. You need to know the length of the fish you're going to put in the tank, and you can use that to figure out how big a tank you should get. So that's what we need to know. So in the next paragraph, it says, if you want 5 2-inch platus fish, 4 1-inch guppies, and 3 a 3-inch loach. So when you read A, you should be thinking, okay, that means I'm just getting 1 loach here. Which is the smallest capacity tank you can buy? 15-gallon, 20-gallon, or 25-gallon? Well, let's take a look. You're going to buy 5 2-inch platus. Grand total of 10 inches there. 4 1-inch guppies. Grand total of 4 inches there. And you're going to buy a 3-inch loach. So we have 17 inches that we're looking at here. So now we look at the graph and we see, oh, well, if you know that combined length on the horizontal axis, then you can use that to figure out the capacity in the vertical axis. Remember, horizontal is with the horizon, just like if you watch the sunset. And then vertical is up and down, just like the columns at the White House. So if we have 17 inches, well, we'd have to go out here a ways. And we certainly could. I mean, we could try to make a good estimate by increasing that line out, but maybe there's a pattern here that we're not seeing. And that's what we want to do. So in this little bubble, it says, how can you use the given graph? You can use the graph to make a table and find a pattern relating capacity and combined fish length. Okay, so let's take a look at this. We're going to use the numbers here, the ordered pairs, and those are the points on the graph, 0, 2, 5, 7, and 10, 12. And that's because those are nice grid points. You know, they work out perfect. 0, 2, 5, 7, and 10, 12. Perfect grid points. Good points, like those. So what we're saying is if you put in a 0, you get a 2. If you put in a 5, you get a 7. And if you put in a 10, you get a 12. Now let's look for a pattern. Is there something easy you could do to 0 to get 2, 5 to get 7, and 10 to get 12? Well, all you do is add 2. That's all you do. That'll get it for you. So what we need to do is say, we're going to put in a 17. And if we add 2 to that, we're going to get 19. We should buy a 19-gallon tank. Uh-oh, that wasn't one of our choices. Our choices were, we're going to buy a 15, a 20, or a 25. Well, you don't want to spend any more than you don't have to spend, so we would get a 20-gallon tank. A 20-gallon tank would do it, and they'd actually have a little bit of extra room, but not a lot. You don't want to waste money. Use a graph to find a pattern, and they have one for us on the next page. Again, these lines over here are for any of those big thoughts, deep thoughts that you had while I was explaining how to do those problems, things that helped it click for you. So let's take a look. This one says the graph shows the total cost of platus at the aquarium shop. How much do 6 platus cost? Use a table. Okay. So our table is about an input and an output and a way to process that. So let's see what we have. Number of platus is on the horizontal axis again. Think of the horizon where the sun sets. And then total cost is on that vertical axis. White House, we've got those big columns in front. So 0 platus in equals 0 on the output. Well, that makes sense. This is about total cost. If you don't buy any, you don't pay anything. Well, on the next dot that we see here, we have a 1 and a 2. Well, we already know how much a platus costs. 1 platus is $2. Absolutely know that now. So 2 platus are 4, makes total sense, and 3 platus are 6. And our process was, okay, well, 0 times 0 is 0, but 1 times 2 will give you 2. 2 times 2 will give you 4, and 3 times 2 will give you 6. So as soon as we found that 1 to 2, we knew that each platus costs $2. Now, if you're saying to yourself, well, what about a buy 2 platus, get 1 free deal? That's not what this graph says. And the reason that I know that is because notice how this is consistent. And what I'm pointing out there is the slope. The slope of this graph is consistent. Rise over run, rise over run, rise over run. And notice it's 2 over 1. So it's $2 for each one of those platus. So 6 platus, $12. And we've got it. And we have our table, so we did exactly what they wanted us to do. It says, how much do 6 platus cost? We've got that. And then use a table. One of the things that I wanted to point out for you in this graph was, they didn't make it a line. Why wouldn't they make it a line? Well, let's look at the label. Number of platus. Well, the fish store could try to sell you 2 1/4 platus. You wouldn't be very happy because it would be a dead platus. So what you'd have to do is realize there aren't going to be any fractions in this graph at all. That's the reason we can't connect it up. No fractions equals no line. And that makes this what we call discrete. This is a discrete graph. A discrete graph is a countable objects graph. These fish, you can't get 3/4 of a fish. You can't get 0.75 of a fish. So discrete graphs are definitely, I don't like the way that was written there, definitely countable objects. And that helps us as well to know, oh, that makes perfect sense that the number of the platus here is just going to be whole numbers, 0, 1, 2, 3, 4, 5, etc. So that could have gone over here as one of your big ideas, deep thoughts. Now our objective had to do with being able to identify these patterns. So hopefully at this point, you're thinking to yourself, in fact, let me put that objective back up here for a second. I'm feeling pretty doggone good about identifying and describing patterns. Sometimes I'm able to write a formula for it. Sometimes I have to describe it in words. But you know what? I'm starting to see them. You know, I can see what's going on. And I'm going to give you the homework assignment here in just a couple of seconds. But notice there are more lines down here. And those lines are for you to write your summaries. You'll notice in the directions that I had on Schoology that I want you each night to go back and think about a little summary. You know, what did I learn to look for here? And write down a comment or two about something that was really helpful to you. Something along the lines of, well, if the numbers go up, I should check for addition, I should check for multiplication, I should check for powers. So logically, if the numbers go down, I should check for subtraction. I should check for division. Those are two logical things to check for. So that's where your summary will go. But for now, there's our lesson, lesson 1-1 assignment. On page 7, you'll do 9 through 23, just the odds. So notice there's the comma there. So that odd piece is just for 9 through 23. 25 to 39, that's going to be all of them. And all of 43 to 57. So make sure that you write these headings on your assignment. That way, if somebody turns it in late, I know exactly where it came from. And of course, don't forget your name. Oh, put that little bad boy on there. That way I know for certain, who deserves the credit for this paper. And as I explained on Schoology, you have to have all of the answers correct. So after you're done with your assignment, turn to the back of the book and check your odds and make sure that things are going well. If something doesn't work out and you need some help with it, check the frequently asked question videos, because usually somebody in the past has asked about those problems already, and I already have those problems on the video. Now what you're going to notice is there may not be a video for lesson 1-1. And the reason that would be is because generally people only have maybe 1 or 2 questions, so we just go over those in class. Hopefully you won't have any questions, but if you do, we'll take care of all that later. So enjoy. There's your assignment.